So here we have another video from ITW, which is entitled, as you can see up there, Unit Step Function and Laplace. And this is a way of modelling real-time systems and transposing them into a format that you can do some analysis on. So we will take a simple function and we'll define it using the unit step function or Heaviside function, and then we will do the Laplace on that, which gives us a format that can be used for further analysis. So let's have a look at a specific waveform. So I'm going to have a go at drawing this. So we need an axis. So here's a little axis there, nice and easy, jolly good. That's 1, that's 0. We'll have a little point here called Tor. This is on the time frame, and this will be f of t. So what we need to do is to draw our waveform, and in this particular case we're going to say that the waveform does nothing until it gets to this point here. It then goes up to 1, and it is at 1 for a period of time, Tor, and comes back down to 0 and then continues as that there at 0. So what we are specifically interested in is at this point here where we switch the waveform on, and this point here where we switch the waveform off. Everything before that point and everything after the off point we're not really interested in because it's just 0. So how do I define this switch on point? Because once I've got it switched on, it'll stay at that point until I switch it off. So using the unit step function way of defining these types of things, then f of t equals our switch on point, u of t, and then the switch off at u of t minus Tor. Let's just analyse those points there. So here is my switch on point. It's at u of t and it's switched to 1, and it's this one here. Had that been a 2 there, then I would have prefixed this with a 2. It's actually prefixed with a 1, I just haven't written it in. And so my function is now running at point 1. And then at some point in the future, and the future is t minus Tor, I then switch the function off. And here is me switching the function off at that point in time. So just to reiterate, my function in this case is t equals u of t, my switch on point, switching off my function at t minus Tor. Good. Now I want to turn this into a Laplace. So here's where I'm going to do the Laplace Transform, and we'll write the word Laplace there to remind ourselves what it is that we're trying to achieve. So I can take these individual elements, so this element here and this element here, I can define them individually because I know from my Laplace studies that Laplace of a function can equal Laplace of function A plus Laplace of function B, and really this would be our function A, this would be our function B, although it is all one function. So let's have a look at this first one here. So that is u of t. So the Laplace of u of t is in fact just the Laplace of 1. And had that have been 2, then it would have been the Laplace of 2. And we know from our Laplace tables that that's going to equal 1 over s. The second one is the Laplace of minus u of t minus tau, and that is going to be minus 1 over s, and that's come from this element just here, and then the shift where that's occurred there is going to be e to the minus s t, and this minus here has come from this minus here. So I can now write that down as a Laplace function. So f of t becomes 1 over s minus 1 over s e to the minus s t. And of course, if I extract the 1 over s out of that, that is 1 minus e to the minus s t. And that there is our answer. It was a bit of a wobbly line, wasn't it? That there is our answer. So if we're asked to define the step function for this waveform, we've done it just here. There's the step function of that waveform underneath all those squiggles, and then we find the Laplace of that. Alright, if I've got enough room here, we may have enough room to do one more. So in this instance, we're going to have a slightly more complex waveform. So let's draw that right now. I'm going to try and draw it a bit smaller, only because I'm going to run out of room. So in this case, I've got a waveform that looks, whoa, look, I've gone underneath there like that. So I've got minus tau there, I've got tau there. We'll leave that as 1 and that one as minus 1. Good. So now we've got to take this as, again, a number of different functions. So let's start by just defining this one here. So that one there, we can say f of t equals, open some brackets up, so we're going to have ourselves some space there. So where am I switching on? I'm going to switch on at u t plus tau, brilliant, and I'm going to switch off at u of t. Let's just quickly analyse that. Here is my switch on. There's minus tau. So, which I didn't write in here, that is t. So I've got my switch on there, which is t minus tau. So that's u, the function u, t minus tau, and it's 1. So it's a 1 in front of that. So it gets switched on just here, and it gets switched off at this point here. So that's the switch off point just there, and that is minus u of t. Then what happens, now be careful about this one, then what happens is you switch on again, and you're switching on at that point there. So I need to leave it in that colour there. So we're going to add the switch on point minus, because it's minus u of t. Can you see that? Minus, and that's the u of t. That's my switch on point. And my switch off point is at u of t minus tau. So my switch off is at u of put that in there, t minus tau. Good. So here is my function that has been defined, and I can simplify that by multiplying by minus 1 and gathering up some of the terms. And I encourage you to stop the video at this point, just have a go at that. So let's do this one in yellow. And where you should find yourself, let's just do a couple of lines. So ft equals, once I gather up all of the terms, I get 2 u of t minus a u of t plus tau minus a u of t minus tau. And you can see where I've gathered up, there's one of my minus taus, one of there, there's one u of t plus tau, and then there's 1, 2 u of t's. So good! Let's do the Laplace on that. So we're now going to do the Laplace of that. And so let's start with this one here. We'll do a different colour, shall we? Yeah, we'll do that colour. So the 2 u of t, remember before I had a single u of t up here, which gave me 1 over s. I've got a 2 u of t here, so here I'm going to have 2 over s minus this one here, which is, there's my 1 over s, e to the, there's a positive in there, so that's going to be the e to the st minus, and I've got this one here, there's a minus in there, so I've got 1 over s, 1 over s, e to the minus s t. And actually, if I take 1 over s out of that, so I take a 1 over s there, 1 over s there, 1 over s there, I could rearrange that to say that that is 1 over s into 2 minus e to the st minus e to the minus s t. And that is the Laplace of that simple drawing just there. And just to reiterate what that drawing looked like before I made all the mess. Okay. That looked like this. I started here, I went up there, I came down to here, I went there, and I went there. So it started at 0, and that was, let's do it in white, minus tau, that's plus tau, that's 1, and that's minus 1. Okay? And that completes this short video on the step function, the unit step function, the have-aside function, and how we do Laplace for that.